Happy Friday, YouTube. How is everybody doing out there? I'm Greg from Greg's Tutoring at GregsTutoringNYC at gmail.com. So we're going to do another lightning round. I think we're up to number 13. So hopefully everybody's doing out there well. You should be pacing and well within your SHSAT meanderings, right? So the lightning round, we're going to spend about 10 minutes going over a problem or so. So I was looking over some of the problems that I still have, as well as some feedback I get from students and so on. And what I'm going to do is put up an example that's actually small, a problem that's actually small and simple, but a lot of kids get wrong. So give me 1 second. I'll pop that into the onto the screen. All right, that should actually work. Let me make the font bigger. All right, let me try to get it on you guys' screens. Let's move this out of the way. Oh, actually, that could stay there for now. So we have this here. Let's make the font just slightly bigger. 1, 2, 3. All right, so it's a simple enough problem, but enough kids keep getting this wrong. All right, let me just make sure the stream is going. Yep, we see them all right. Okay, so we have the length of the side of a square is 5 centimeters. The lengths of the sides of that square are increased by 20%. By what percent does the area of the square increase? So let's take it a sentence at a time. So we have a square. On a test like this, it's almost always worth writing it down instead of doing it in your head. So we have the length of a side of a square is 5 centimeters. Okay, so that means this is 5, that's 5, that's 5. Okay, so it says the length of the side of the square is increased by 20%. By what percent does the area of the square increase? So this square S, the area of S right now is 25. Okay, centimeters squared. All right. So here's where kind of the fallacy goes in. A lot of kids just do this in their head. They get that, and then what they're going to do is increase this by 20%, so which is the same as 20 over 100, or if you know it's 1/5, right? So they're going to get that's equal to 5, right? And they're going to add these two together and get 25 plus 5 equals 30 centimeters squared. Because obviously, if this is 5 and 5, and the sides increase by 20%, then the whole thing increased by 20%. But the truth of the matter is that's not how it works. This is not perimeter. We're not asking for the perimeter of the thing. Where the lengths of the sides increase by 20%, we just add them up that way. So we could do 4 times the sides plus the 20%. Okay, this is squared. It's squared. So it means we're getting 20%, the 5 times the 20%, plus or times the other 5 times the 20%. So that means we're going to do the 20% twice, and we're going to multiply it. So we get a kind of an uglier problem. All right? So if the length of the side, S equals 5, what we want to find is the new length of the side. Right? So if we get 5 times the 20%, which again is the same as 1/5, so that is equal to 1. So at the length of a side, this is the original, so this is the side, the new side, it's going to be 5 plus 1 equals 6. Okay? And then we want to know, so that this was the area of the original S. So now we have a new square with sides of 6. So the area of this, let's call it N, so the area of N is equal to 36 centimeters squared. Okay? So now we have a difference between the original 25 and the 36. Because the answer is not 25 or 36. It wasn't 30 either. The question is what's the percent increase? Okay? So if the length of the side increases by 20%, what is the percent of the area increases? All right? So with that, we basically have 36 over 25. So we have to do that division. So we have 25 goes into 36, right? One time, and we get what, 11 left over? So that's 5, that's 5 is too big. 4 gives 80, 90, 110. Did I do that right? 0, 8, 9. No, it gives 100. So we have 10 left over, and we get another one there. So we get 1.44, and that's the percent. In other words, this is equal to 1.44. So 100% is already 1, because 100% means 100 over 100. So that's the increase right here, is 0.44, or 44%. All right? We could have also done this a slightly other way, which is instead of doing the 36 over the 25, we could have done 36 minus 25 over 25 and gotten 11 over 25. So this is the new and the old, and this is just the old. Here we're trying to get the difference between the two of them. So now if we do 25 over 11, because we had 25 over 25, if we add these two, we get the 36. So we're getting rid of the 1. So this should end up being 0.44. So if we go 25 into 11, we get the same issue. We get, this is 0, we get 4 is 100, so we're left with 10, and it goes into here. So we get the 0.44 that way as well. Okay? And there's something that kind of leaps out here, which is that once you realize this is what happened, and really what we're doing is we're focusing on, it's the side times 20% times the side times 20%, right? So we're getting at the side squared times 20% squared. 20% times 20%, right? So whatever that is equals whatever's going on here. And we originally started out this with 5. So whatever happens, this is the difference. That's the difference. So we're getting really 1.2 times 1.2, right? And 12 times 12 is 144. And if we put our decimal point in the right place, we get 1.44, and voila, we get the same number here, that it's a 44% increase, right? S stayed the same. If we consider that S stayed the same, and the only thing moving is the 2% on top of it, right, the 20% squared, that's what that's going to be here. All right, and that's our increase. All right, so this is a classic one. It's on a lot of standardized tests. It doesn't show up on every SHSAT, but it shows up on enough. And it could show up in a grade 9 one with a twist. Okay. So let's do another one kind of in reverse. Let me cut and paste that. Let me make sure we're still running and there's no questions. Okay, we're good. 1 second still. Okay, so this problem is slightly in the reverse. So if in the other one we were trying to get the new area, and then figure out what the difference was. So we have the area of a square is 256. If the area is decreased by 15/16, by what percentage does the length of the side of the square decrease? So it's really the same problem in reverse. So let's start out with the problem. We have the area of a square is 256. Okay, we don't care what units in this example. Okay, so since it's a square, we have s, so we basically have x squared equals 256. We take the square root of both sides, and we get s equals 16, right? I told you guys to remember your perfect squares up to 20 times 20. So in any event, you can calculate this. You can guess 12, 17, and end up with 16 here. But you want to save seconds. You have a minute and a half to answer each of these questions basically on the real test. So you want to get that. So this becomes 16 and 16. All right. Then we're told the area is decreased by 15/16. Right? So there's kind of two ways to do this. So original area is 256. If it's decreased by 15/16, it means we're just left with 1/16 of it. And we have this kind of the same thing. Once you figure this out, then you're going to get 256 over 16, which you should know at this point is equal to 16. So that's our new area. Our new area is 16. So we have an area of the second square equals 16. Well, if we have side squared equals 16 here, then with the square root both sides, we get s equals 4. All right? And now all we want to do is compare the two side lengths. We have 4 to 16. So that's 25%. Okay, and it asked, how much does the length of the side of the square decrease? Well, it went from 16 to 4. So it decreased by 75%. All right, so again, both again, we had the original question, which is often on the test. This gave a little twist to it. There could be other twists to it, as all questions already have. All right, so I'm going to keep this lightning round at basically to this example. Let me make sure there's no questions here. No, there's not. All right, so happy Friday. I will probably do a longer stream with the SHSAT-like ISEE problems. As some of you saw, they were getting hotter and tougher, and they're going to continue to do that. They're definitely grade 8 and grade 9 problems. All right, everybody have a good weekend.